With the help of Langchain Stream, you now don't have to wait for entire response to get generated by large language models in the Streamlit application. Further, watch this video to implement open source LLM RAG without generating prompt in the response.
If you're building a RAG or chatbot application using Langchain, then there might be some point where you need to deploy this application. This is where we have multiple framework or libraries in Python such as Streamlit, Chainlit, or Gradio. This particular frameworks helps you build a web app application without any prior knowledge of HTML, CSS, or JavaScript. When you deploy your Langchain on Streamlit, there are multiple challenges one faces if you are using open source large language model as your LLM. And the common problems are you need to deal with how you can exclude the prompt in the response, because in the recent days, I've seen the prompt is being generated in the response. So you need to remove this. And there are also challenges on how you can reduce the delay time in generating the response. This is where we have Langchain Stream, which we will use in this video. And again, this particular video is part 4 of open source LLM series on Langchain and HuggingFace. It's very exciting because this is my favorite video in the entire playlist, because we will deal with Langchain streaming and also how you can exclude your prompt from the response which is getting generated. Alright then, so let's get started. At first, we will convert our data into embeddings and store that in a vector database. The entire process will be saved in a persist directory. Persist directory, if I have to give you an example, let's imagine you're building an application where you have a data and there are chances that you will upload the same data for multiple times, and creating, embedding and storing it in a vector database for each time, it's very time consuming. This is where whenever you upload a new data for first time, you need to create vector database only once. Create an index of it and store it somewhere. If you are using in-memory, use a persist directory. If you are using a cloud, use a collection name or index name. So let's quickly build an architecture flow or application flow to understand what and all components we need to build a Streamlit application using Langchain. So the first step, as I said, we need to convert our data into embedding and store it in a vector database. So we spoke about 3 components. We have our data. This data can be PDF or any other format. It can be CSV, Markdown, JSON, any other thing. Once we have our data, the next step is we need to create smaller chunk of it, because there might be chances your PDF is very long and retrieving relevant documents on complete data doesn't make sense. That's where we need to have specific chunk where our input lies in. That's where we need to create chunks, which is smaller segment of your original data. And then for our entire text chunk, we need to create embedding. And we will be using open source embedding models. Just like we did in our part 1, part 2, and part 3, we create embeddings of our data. And later on, we will store that in a vector database. So here vector database also will be open source vector database, which is ChromaDB, BB8, Milvus, Qtrun. In our case, it will be ChromaDB. Let's connect this by arrow marks. We have our data, create chunk, then convert into embeddings, store this in a vector database, and then in ChromaDB, you have a variable where you need to define your persist directory. And let's imagine our persist directory is a variable. Our persist directory is a variable named as DB. So we will save it in our DB. So this particular DB will act as our vector database now, which is already indexed. All right. So now what we need to do is we need to proceed with further step. That's with RAG. Now what we have done is we just looked into the first part where you are converting your data into embedding and storing it. In the second process, we need to look into RAG application, that is retrieval augmented and generation, we have three parts, but the major ones are retriever and generator. So let's start with retriever. In retriever, what we need to do is we have a user. This user will write a prompt. Let's say he will write a prompt. And once he writes a prompt, it's nothing but a text. We need to convert the text into embedding. I'm just drawing it very small. We need to create the embedding of it. And now what we need to do is, whatever embeddings you have, you need to look into your vector database, which is your persist directory, and do search technique. It can be similarity or anything, maximum, marginal, relevancy. You need to do the search technique and retrieve the relevant context based on the user query. So now what we need to do is, this embedding will be checked in our database and it will retrieve the relevant documents. Retrieve relevant documents. I'll just write docs. And here you need to define two types. One is search type. Search type you need to define. And also you need to define K. K is nothing but how many relevant documents you need to retrieve. So you need to define your K. Search type, it can be MMR or similarity. Alright, so let's proceed. Now what we need to do is, we need to bring in our large language model. So our large language model is nothing but our LLM. It is open source. Obviously, we'll be using HuggingFace, what we did in part 1 and part 2. Also, we used LLM, which is open source in part 3. So now we have different components. We got a user. Let me quickly draw the arrow marks. We have a user. He writes a prompt. That prompt gets converted into embedding. This embedding looks into vector database and retrieve the relevant context. We have context. We have large language model. We have solved the issue of retriever and generation. Prompt is also very important. We need to define a prompt template. Prompt template. It's nothing but augmented. So I'll just write augment prompt. So let me drag this so it's visible. Okay, so now what we need to do is, we need to use a chain. We will use a chain. Chain is nothing but our Langchain expression language. We need to define our chain. Chain is Langchain expression language. So using this, we will use a feature called streaming. So here we will mainly use this chain to stream. You can also use for batch. There is also invoke. There are different methods that you can use using Langchain expression language. Our main focus will be streaming. So now what we need to do is, in order to create chain, you need to pass the context. So this context, it's nothing but your first R. R stands for retriever. And the second is A, which is your prompt template. You need to define your prompt template, which is your second part of retriever, which is A. And third, we have language model, which is our generator. And now we have G, which is our generator. Retriever augmented generation. So we need to pass, this is generator. Okay, so we have retriever, which is our context. We have our prompt template. So let me draw this arrow mark. We have a prompt template and we have a large language model. Combining all this will create a chain. So once you have chain, you just have to stream and return a response. So now what we will do is, after you run a chain, you need to generate a result or response and then pass this particular response back to the user. It will be tough to draw it, but let me see if I can do it. This particular response goes back to the user. That's it. So let me revise it again. you have the data where you're converting it into embedding using chunking, and then you save that embedding into vector database. This vector database is saved in a persist directory, which is in memory using ChromaDB, and we just name it as a variable DB. Now we will move on with the RAG application. In RAG application, we need the user to write a prompt. The prompt is converted into embedding. This embedding then looks into database, which is your vector database. After performing your search technique, it will return the relevant document based on your two parameters, which is search type. By default, it is similarity and K. And once this is done, you have your context. Use the prompt, large language model, relevant context, combine all these things in your chain, and your chain will return the response via Langchain expression language using streaming. So this is the entire flow that we need to code. So let's get started with the coding part. The first step is installation. We need to install Langchain community, then PyPDF. This is used to load our data. And we also need HuggingFace Hub so that we can use our large language model. And we need ChromaDB, which is our vector database. And lastly, we need Streamlit, which is our major thing to build an web app. And now there is a disclaimer to those who are watching this video for a very first time. This is the part 4 of our series, as I mentioned earlier. In part 1, 2, and 3, we have already looked into how to store our data into a vector database. If you're not familiar with it, then please do watch the starting 3 videos. If you know how to store your data into vector database, then you can proceed with app.py. But before that, let me just show you how you need to store it. You need to create 2 files. One is app.py, which is we will write freshly, and one more is Ingest.py. In this particular file, we are taking our data and then we are creating the chunk of it, and we are using vector database, and we will pass our chunk and embedding to the vector database as we looked earlier into the diagram. And then, since we are using HuggingFace Inference API embedding, this particular component requires HuggingFace access token because we are not loading the model locally. We are just using the inference of it, which will run on HuggingFace Cloud. It will save our time. So we are using the HF token, and I've already saved my API key inside a new Python file, and I'm just calling it. So you can directly add your API key. In my case, I've created a new file. Now this process is same. We have repeated this 3 times in past 3 videos. We load the data, and once you load the data, you need to chunk the data. And after chunking is done, you need to use embeddings, pass both your chunk and your embedding into a vector database. One new thing in this video is the persist directory. So what you need to do is, for each PDF data we upload, create a persist directory. I've already created one data. If you can see my main function, I've used a sample data, which is my Ikigai ebook, and I'm creating a persist directory to it. That means this PDF is converted into chunks. Then using embeddings, I've saved it in a persist directory. So if you see my files, I have my data folder. I also have DB, and I've already created a vector database for it. So let's proceed with app.py. In your case, you need to write this code. Not to worry, the entire source code is available on GitHub, and you will find the link in the description. And this is similar thing which we have repeated multiple times. So I'm not writing this code from scratch, but this is where we will be writing code from scratch. And let's get started. We need to import few statements. We need to import few packages. So let me quickly import it. Import OS. I will zoom this screen. We will import OS. We also need my API. In my API, I have my HuggingFace token. That's why I need to import that. And then I also need to import Streamlit. From Streamlit, not from Streamlit. I'll just import Streamlit as ST, which is the short form for Streamlit. And then I also need time. The reason why we need time is for streaming. And I need auto typing of my response on Streamlit app, which takes few delay of time. And that's where we need time library. And now we will come with the Langchain. And in Langchain, if you look at my diagram, which I built earlier, there was part 2. In part 2, we had the user who writes a prompt. That prompt also needs large language model and it also needs ChromaDB. So let's quickly use that particular diagram. In this diagram, as you can see, we have prompt. We need a prompt component. We need an embedding component. Since we have persist directory, we also need a vector database component. We need a large language model component and we need a chain. And that's it. So let's quickly import those statements from Langchain. First, I will use our large language model, LLMs, import HuggingFace Hub. So this will be my first statement from Langchain community, HuggingFace Hub, and then Langchain community dot embeddings. I need to import HuggingFace API inference API embeddings. So as you can see, it is showing me the drop-down menu for suggestion. HuggingFace inference API embeddings. And then I also need my vector database, which comes in vector stores. I need to import Chroma. It's capital C. And next, I also need my prompt template. And in order to use prompt template, I need to use Langchain core dot prompts, import chat prompt template. And now there are two more things that I need to use. Since we are using Langchain expression language, in part 2 of the video, I introduced to something called as runnable pass-through, because initially we don't have any user query. When you build a chain, user is not writing any prompt. So we need to pass that. In order to pass that particular variable, we need runnable pass-through. From Langchain dot core, we need to use runnables, import runnable. There should be something related to pass-through. From Langchain underscore core dot runnables, import runnable pass-through. And next thing is, I also need my output parser. So this is already covered in part 2. If you are not familiar with it, please do check out part 2 of the video on advanced RAG. Now what I need to use is, I need to use output parsers, which is nothing but my str output parser. So these are the few import statements that we need to use. Our large language model, embedding, vector database, prompt template, runnable, so that I can pass my query. And then whatever output should be there, it should be in specific format. All right, so this is done. Let's quickly call my HuggingFace token. I need to define my HuggingFace token and save that in a, we need to save that in an environment variable. HF token equals to my API. Inside my API, I have something called as getHF key. So in getHF key, I have my HuggingFace token. So I need to use that. HuggingFace token is free. And how do you get your HuggingFace token? It is already done in part 1. You just have to go to huggingface.co, get into settings, go to tokens and get your new token. Once this is done, you need to create an environment variable. And inside environment variable, write exactly as I write. Everything should be in caps. HuggingFace Hub API token. And I will save it into HF token. So once this is done, now comes the very interesting part. In Streamlit, whenever you enter any text area, it will reload the entire website. This is where you need to use caching for each function you use. Again, I'll repeat, when you are building an application using Streamlit, you need your entire application to be stored in a cache so that whenever you write a prompt and enter your prompt, it doesn't reload the website. In order to avoid reloading, you need to use cache, which is cache resource. You define this cache resource, and now we need to write our code. And in order to write our code, first thing is, let's look into our diagram. The user will write a prompt. Whenever he writes a prompt, we will use our embedding, get into vector database, and retrieve the context. So what we will do is, in our first function, we will work with retrieve documents. Retrieve documents doesn't need any parameters. I'll just use pass. I'll come back to my flow, and this is my first part: app user, prompt, embedding, database, get the context. So till here, this is my part 1. In part 2, I need to create a chain. So my part 2 will be set cache resource, and in my resource, I need to create a chain. And if you look at this chain, I have a LLM model, I have a prompt, I have a retriever. This retriever, what I'm having, the retrieve context, it is from different function. Okay, it is from outside function. So I need to pass a argument. I need to pass an argument, which is nothing but retriever. And make sure you're using a hash symbol. So in caching, internally it does hashing. That's where you need to use underscore and then write your variable. And I'll just use pass. So these are my 2 functions that I need to use. And then I will have my main function. In my main function, this is where I will have my Streamlit application. My application. So this is the sample app that we will build in this particular video series. And now what I will do is, I will simply run this. Name = main, and I will call my main function. So let's see how our application looks like. And in order to run Streamlit, you just have to run Streamlit run app.py. And once you run this particular statement, it will give you a local host URL and it will redirect you to the browser. In my case, it's going to take few seconds because, yeah, it's already given. This localhost will give you the link and automatically redirect you to a web browser. So if you look at my code, I have not written anything. Only import statements, 2 functions that we need, which is retrieve document, create child, and the main function. In main function, I have a Streamlit title, which is my application. This is it. I have only my application on my website, if you can see. So now what I'll do is, I'll create a subheading and I'll write Streamlit and Langchain Stream. So if I come back to the website and if I click on R, it will auto rerun, and as you can see, it is showing Streamlit and Langchain Stream. Now what we need to do is, we need to give user a choice whether you need to upload a new file or whether you need to use the existing index. Since we are doing this video series, what I need to follow is, I will use the existing one because uploading a new PDF file and waiting for indexing might take few minutes. So I don't want to take that risk in the live coding. So what I'll do is, I will give a choice to the user. Streamlit, on the sidebar, I will create a select box. I'll tell choose. Choose is nothing but you'll choose his choice, which is my label. And one will be upload. Upload in the sense upload your file. And second option will be existing. Choose your data. So one you can use upload, if not you can use existing. If I rerun this again, as you can see, I have a sidebar which has upload and which have existing. So what do I need to do? What do I need to do if my choice is upload? I need to upload a PDF file. So the first thing is upload my file, I will use a component called streamlit.file upload your file. So this will be my statement. Whenever I have to upload, user will upload his new file. And what will be my else condition? In else condition, I'll just tell user to write his prompt. I'll tell him to directly write his prompt in my chat window. I mean, in my text entry box. Enter your prompt. And if I come and if I refresh this page, as you can see, I have my application Streamlit and Langchain Stream. Let me remove this. This was just for understanding purpose. Now if I come and refresh this page, as you can see on my left hand side, which is my sidebar, when I click on upload, I have a file upload option. And if I use existing, I have to directly write the prompt. And in this case, we will be using existing, but I'll give you what you need to do when user needs to upload a new data. So you need to just call your persist directory. Just use Ingest.py and pass the file into persist directory. So if you look at my Ingest.py, I have a function called persist directory. You just have to pass file path and you need to remove this. You need to remove this and you need to pass your file path. But before that, what you need to do is, whenever user upload a new data, create a directory, save the file in the directory, use that path and call Ingest.py. So in Ingest.py, you need to pass that particular file path into your persist directory. I'm not doing this part. It is very simple and I'll let you guys do this particular if condition. If in case you get stuck, there is a Discord link in the description. Join our Discord channel because people are recently very active and asking questions. You can do it too. And if in case you feel any trouble in this particular step, do reach out to my Discord channel. The main thing what we need to focus in this video is how we can use Langchain Stream with Streamlit. That was our main focus of this video because this is very simple, man. If you are using Langchain and if you are building Streamlit application, this shouldn't take that much of time. And I don't want to write this code because it's very common. Now we will focus on this part. So now what we need to do is, let me fill few component. Now when a user comes, what we need to do, just a second, let me remove this file. So now when the user comes, we need this user to write a prompt, convert this into embedding and look into our vector database. So let's write our retrieve document function. The first step is you need to create your embeddings. I don't want to write this code again. I'll come back here. I'll copy this code. I'll come to my app.py. I'll paste it here. So you're creating embeddings. You're calling HuggingFace API embedding. The model that we are using is BAAI BGE base English model. And we are using HF token, which is my access token. And once you have your embeddings, the next step is you need to retrieve your documents. How do you retrieve? Get into Chroma and pay very close attention. I'm not storing, rather I'm using my persist directory to load my DB. And here I need to pass my embedding function. Which is embeddings. This is it what we need to do. We need to create embeddings, which is just a single line of code. And then in Chroma, we need to define our persist directory and define our embedding function. Now what we need to do is we need to retrieve. I just have to write retriever retriever is nothing but db dot as retriever. And here you need to define your search type. Search type I'll use default, which is my embedding, not embedding, similarity. Search type by default is similarity, but obviously I will change my keyword search parameter, which is search keyword arguments equals to k is 3. So this will be my retriever part. I need to use embedding, define my vector database, use my vector database as my retriever, and define search keyword arguments as k equals to 3. All right, so far so good. Now what we need to do is we just return the retriever. We have solved the first step. If you come back to the code, block diagram, we have a user query, and once we get the user query, we create the embedding and look into a vector database, which is a persist directory, and we return the relevant document, and we define search keyword argument k to be 3. And we have done that. Let's proceed with the second part. In the second part, the first thing is we need to define a prompt template. So how do we define our prompt template? First, we need a template. Just write your system prompt and user prompt. And I'll quickly copy it from my previous code. Let me copy it from my previous code. Just give me a second. You can use your prompt as well. I've already written my prompt, so I'll use the same prompt. So this prompt is nothing but there is a user. He will write, you are an AI assistant that follows instructions extremely well. Please be truthful and give direct answer. Please tell I don't know if user query is not in context. This context is nothing but your retriever retrieving the relevant documents. And then keep in mind, you will lose the job if you answer out of context question. So this is my prompt, which is my system prompt. And then I will pass this particular context and query. I'll remove this. So there should be a user prompt and there should be assistant, which our LLM model needs to generate. So this is my prompt. I have defined my prompt. The next thing is we need a large language model. So let's define our large language model. LLM equals to HuggingFace Hub, and there are few keyword arguments that we need to pass. The first keyword argument will be the model that you need to choose. The model is nothing but your open source LLM model. And in HuggingFace, we need to define the repository ID. The repository ID is nothing but HuggingFace H4, and we will use Zephyr model, which was fine-tuned on Mistral model by HuggingFace. That's where it is written HuggingFace H4. Zephyr 7 billion parameter alpha model. So this is my large language open source model. And then we need to define keyword arguments. Model keyword arguments. The first thing is what should be my output result? The maximum new tokens. Max new tokens. What should be the size of my response? I'll just name it as 512 tokens. And I will also add a repetition penalty. Repetition penalty, it's mainly used when there are few answers, it is repeating multiple times. And I need to add a penalty for it. So repetition penalty, the spelling is correct. I'll keep it as 1.1. And then I need to set a temperature value so that my model doesn't add any creativeness. I'll make it as 0.1. And then I will return something called as return full text false. This is the most important argument that we need to use. Not many people uses this argument. I'll tell you what will happen if you don't use this. When you directly use a large language model, you add a prompt, it will generate a response. In this response, it will also include your prompt. If you don't want your prompt in the response, do include return full text. This is the most important part of this video. and not many people uses this, you need to define return full text false so that it will not include your prompt in the response. And there was one comment in my previous video on how to avoid adding prompt in the response. This is how you can avoid it. Just use return full text to be false. So we have a template, we have a large language model. Now we need to use a prompt for my template. Prompt equals to chat prompt template. From template, I need to define my template. So this is my augmented prompt. As you can see, LLM done, prompt done. This particular retrieve context, I need to pass to chain and I need to combine it and then use stream. Stream is the second most important of this video. The first part is done. First part is how to avoid prompt in response. Check. And now we need to create a chain. And in order to create chain, there are two more parameters that we need to define. One is our output parser. I need to use stl output parser. And then I also need to define my chain. Now what I'll do is, I'll define my chain. Chain equals to, there should be argument. So inside chain, I need to have a curly brackets where I need to define my context. And I also need to define my question. So just a second. Context and question. So this question is nothing but runnable pass through. In the beginning of the video, I told you, question is initially not given by the user. So we need to pass. Question is not given, just pass. Now context is our retriever. So what we will do is, we have already used retriever as our hashing symbol in the function. Copy this, paste it here, and you need to set the config. With config, you need to define run name to be docs. So what we have done, in the first step, we have used a function called retrieve documents, which will convert our prompt into embedding and look into the Chroma vector database, and it will return the relevant documents with k equals to 3. And in create chain, we need to define a template, use a large language model, and the augmented prompt output parser will be passed to the chain. So in order to use Langchain expression language, we need to use pipe symbol. Pipe symbol is nothing but this straight line. So after this step, we need to create a pipe. Just a second. You need to create pipe and write prompt. So first is your prompt, and then again create a pipe. Then write LLM. Again create a pipe and write your output parser. So I'll just repeat what we have done. We wrote our template, and in template we have defined two input variables. Pay close attention. In our template, we have defined context and question. These two things we need to define it in our chain by adding both the input variables. Question is not given by the user, so we just have to pass it. Retrieve context, you need to set up the configuration and then create a pipeline. By using the pipe symbol, we need to add prompt, we need to add LLM and the output parser so that we get the response in the relevant context or relevant format. So now what we will do is, since we need to create the chain, we will just return the chain. Return chain. That's it. That's it what we need to do. Here we will use the stream. And the most important part of this video is how do we auto type in Streamlit. And in order to auto type in Streamlit, we need to define container. And this container is empty. I need to define container which is initially empty. I'll define my container which is empty, and full text, I need to define a variable, because when you need to auto type, you need to set a limit of time. and each chunk is your response, which will combinedly form your full text. Now what you need to do is, you need to call your chain. You need to call your chain and create chain. Inside create chain, you need retriever. And in order to get retriever, you can directly pass the argument. What is the function? The function is retrieve documents. Copy this, paste it over here. That's it. So what we have done so far, in the main function, we have our heading, and then we have side box, where for upload, you need to write code for, or you can call the Ingest.py, and it will create DB. It will create DB for you, and you have the code for that ready. And if you're using the existing one, we need auto type functionality so that we don't wait for the response. And in order to do that, we have created two caching function. One is create chain and one more is retrieve documents. And once you have the chain, you need to run stream. You need to use stream. And how do you use this? For chunk, let me zoom this. For chunk, in chain.stream, whatever prompt the user enters. If you see here, we are waiting for the user to enter a prompt. We just have to write prompt, and then we need to use words equals to chunk dot split. And once you split the data, for word, in words, full text plus, you need to add your word by word, and you just have to write space after it. And then you just need to update in your text container. And text container, you can either use write or markdown as you feel, anything based on your choice. I'll probably use write so that it's very simple. Write, and you just have to write your full text. That's it. This is it what you need to write. And time dot sleep, and you need to define 0. Let it be very minimum, 0.05, so that we can see the delay in the word getting generated. That's it. So this is our entire application which we have built. Now let's test it out. Let's come back to our Streamlit tab. And in Streamlit tab, let me refresh this. Once you refresh, let me refresh this entire web page. In the existing, you just have to write your prompt. What are the 5 lessons from the book? So once you write the prompt, you don't have to wait for the response, and it will generate. As you can see, you just have to don't wait. It will generate the response. Don't worry, keep your art young, cultivate good habits. These are the, okay, I asked why, it is just telling to, let me rewrite this prompt. 5 lessons from the given book. And now if I enter, it will auto type your response using Langchain Stream. So as you can see, it has given 5 responses, and we didn't have to wait for the response. It will just auto type. That's the power of Langchain Stream. You can use different prompt. I'll just write name the authors of the book Ikigai. And I've just written this prompt, and you just have to wait for a few seconds. The authors of the book Ikigai are Hector and Francis. I hope I named it correctly, but that's fine. So these are the responses, and it's very quick. You can try as much as you can. Which country is the book mainly focused on? So I probably need Japan as my response. So let's see if it is giving Japan as the response. The given material does not provide. Which country is the book mainly written about? So there is one more feature that we need to add, which is query rewriter, which will convert your entire prompt into a template which is directly passed to a LLM model, which understands the context. And Query Rewriter is recently used in many use cases. And as you can see, the book Ikigai, The Japanese Secret to Long and Happy Life, is mainly written about Japan. So we are getting the responses, and there are few advanced techniques you can use. If you look at part 3 of the video, we use something called as hybrid search. Just implement hybrid search in this particular use case, and it will work very fine. And where do you find all this source code? You have an awesome RAG GitHub repository, and the link is in the description. You have all the Colab notebooks in that particular repository. Just go out there, copy paste, and build an amazing application. So these were the two main focus thing for this video. The first focus thing was how you need to use Stream, and you just saw how fast the responses were. And the second thing was, how do we not include the prompt in the context or in the response? This is how you can do it by using return full text to be false. So this is it from the video. I hope you enjoyed it. And obviously part 5, part 6 is still yet to come. And then we will have end-to-end project implementation. Until then, goodbye, and do subscribe to the channel.